So essentially, we have two parts. Can you see my screen? Type yes if you can in the chat. Okay, wonderful. So essentially, we have two parts. If you look at here, so the part one is programming basics. We have two sessions for programming basics. That will be now, this session, this meeting, and the same time tomorrow. So we have two sessions. What we're going to cover? We're going to cover like a basic concepts of programming. We're going to cover like variables, data types, controls, and in next session, we're going to cover procedures and the basic data structures like a list and a dictionary. If you are not familiar with that, if you heard about these terms, that'll be great. You do have you're not starting from zero, but you know something. If you don't have programming basics, don't worry about that. We will introduce that for you. Okay. So and also we have the second. Well, as a second part, that will be the crash course. We call it actually the project-based crash course. That would be session 1, session 2, 3, 4, and 5. In this session, we're going to focus on the projects, the very practical projects with MIT App Inventor. So what you're going to cover is you're going to cover a lot of things, not only the contents that we covered in the programming basics, but also we're going to extend to multimedia, animation, sensors, cloud storage, map, interactive map, like a Google map, and navigation, which means if you know your location A and the location B, what is your driving direction? So all these are doable in our program. That's very cool. And also in the last lesson, we're going to cover an advanced content, which is called a web API. What is a web API? Essentially, if you have a program, right, you want to find hospitals around you for COVID. If in the COVID period, we're looking for like a medical services around us, where we can get a vaccine or testing, right, virus testing. So who has that information? We don't, but some services has. So we're going to pull information from there. Combine all these technology and the programming skills, we should be able to make useful, impactful applications, right? So that's the purpose of this course, this whole crash course. Okay, so instructors in teaching staff. Our instructor will be Rithvik, Ganesh. He will be a freshman at MIT. I introduce him a little bit more later. We have some other instructors. So Rithvik will cover this meeting, and we'll cover a couple of sessions. Okay, another instructor will be John Rowe. John Rowe will be the sophomore. Next semester will be second year student at Harvard. Both of them, both Rithvik and John, they will be they are pursuing degrees in computer science, right? And also, I'm very glad we have a teaching assistant here, Ambrose Law. Okay, he's from Troy High School, which is the very famous public high school in LA, right, Los Angeles. So myself, my name is Yu Ming. I serve as a chief coach in this San Ramon hackathon. All right. So, any questions so far? Yeah. Anytime if you have questions, you can feel free to type it in the chat. Me or TA or our instructor will respond to you. Okay, so yeah, how to take the advantage, how to learn well, how to work well with this course, right? Just number one, be present on time in the class. Don't miss it. Okay. So during the class, you should follow the instructor and repeat the in-class lab, because a lot of times, I mean, teacher gonna show you some examples, gonna do program, especially in the MIT projects, right? There is each meeting, each lesson, we will cover a couple of projects with MIT App Inventor. If you can, yeah, just follow the instructor and repeat it. So on your PC, and well, you're gonna repeat what the instructor doing, right? So that you will learn that way. It's a better way to learn. Okay, so well, is that the end of the? Is that all? No. This is what I recommend. After class, you should review the video or PPT slides that your instructor provides. We will post these in a place in the Discord group. Okay, here's the Discord group. Let me send the link of the Discord group. You guys can. Let's see. Yeah, it's right over here. Okay, I will paste the invitation link to the chat. Are you able to get in? Are you able to open it? I mean, click on the link that I sent to the chat. Yeah, and join the team. Oh, I see a couple of guys just join. Yeah, the group, I'm still setting up the group, but yeah, you can join the group. I will have someone to, to better organize the chat, the group. Okay, I heard a lot of beeps. Yeah, thanks for joining. All right, so yeah, while you are trying to join, this is the slides I got it from somewhere, right? So what is the key to learn programming well? Well, essentially, if you look, let me read it for you. If you're looking for one key to learn a programming language well, a key that is missing from many other factors, like well, if says what is the important factors for for you to learn well in programming? A lot of guys saying, hey, yeah, so how's the quality of this course? How's the good course, good instructor, good books, right? Good video and other resources. But one thing is, but the most important thing is, I tell you, I agree, I totally agree with this, immersion. That is, you're gonna actually write, do a lot of code writing, right? You're doing debug, which is problem solving, troubleshooting, right? And modify a lot of code in the language. So that means you're gonna practice a lot, okay? So in the class, this class is not like some of other classes, other courses. So for this class, you're gonna bring your brain and your hands together at the same time. You're gonna practice, you're gonna listen and think a lot, and also you're gonna practice a lot. This is the only way that you can learn well in programming. Okay, so this is the key. Remember that. Okay, I know a lot of some other courses you can just pay attention, just listen, focus on, just listen, right? Just listen and think. But this one, you're gonna bring your hands. Okay, bring your hands. That's very important. All right, so yeah, let me introduce our instructor, Rithvik Ganesh. Okay, Rithvik is is a rising student at MIT. During high school, he won a lot of. He's really good in math. If you look at here, his major achievement, including grand prize in the International Science and Engineering Fair, and 2 times AMO or JMO winner. He's a 2-time JMO and a AMO winner. That is so impressive. And he has 5 times in the state. He has a 5-time winner in the Texas Science and Engineering Fair. So I'm really happy that Rithvik can teach us to study MIT App Inventor. So so I would like to invite Rithvik to the stage, and I'll hand over the control to you.
All right, hi guys. Thank you, Dr. Meng, for the introduction. I'm really excited to be here, and of course, we're just going to go ahead and get started with some of the basics of programming, and then getting all of you guys exposed to MIT App Inventor. Just throughout the, as I go through the slides, feel free to just go into the chat and ask questions. We also have the TA Ambrose, who can answer some of your questions. And some of them I might be able to answer myself, just answered while I'm going through the slides. But just to start off, I'll go ahead and share my screen here. All right, so we're going to go ahead and get started with MIT App Inventor. Just an introduction for you guys, getting exposed to what it is. And before we start off with this, I want you guys to just think big picture about what programming is. Essentially, when you're programming, what you're doing is you're using logic, math, and then a series of commands to do cool things. And by cool things, those applications are growing, right? Dr. Meng talked about like COVID-19 applications, making your own apps to solve different problems that are important to you. Almost all businesses, like if you see today, they use programming in some way to meet their mission. And programming is, I guess, the skill of the future. It's like reading and writing, but for the 21st century, programming. And that's what we're going to be doing, and specifically using that in the context of MIT App Inventor. All right, so MIT App Inventor is basically a system. It's like a platform that you can use to create versatile apps. And one of the really good things about MIT App Inventor is, especially for beginners, it uses block coding. So like what you see here, it uses blocks. And so what that does is it abstracts away, like in Python, if you wanted to use Python or another programming language, you would have to type out your commands or type out what you wanted to do. But for MIT App Inventor, it just talks about like the higher level functionality and reduces that to a simple drag and drop block that you can use. And that makes it really easy to digest and process. And also another thing is that it's really easy to export your apps and then test it. So actually in a few minutes, what we're going to do is actually set it up on your phone or emulator. And what you'll see is that you'll actually be able to use your app directly and test it straight from the website. All right, so now what we're going to go ahead and do is get started with before we get started with the MIT App Inventor setup itself. I'm just going to show you how it's going to look like, just at a bigger picture. So MIT App Inventor, the way it works is there's really two big modes in the entire thing. There's a designer mode, and then there's blocks. And so designer mode is like the visuals, what people are going to see. Like you can see, like in designer mode, we can control the screen, some of the colors, alignment, left, right, center alignment, and all of these different things. And you'll see as you play around with MIT App Inventor, there's a lot of different user interface elements that you can add, like images, buttons, spinners, switches, and all of that is in designer mode. And it's going to look a little bit like this, where you have your palette on the side with the design elements, the screen right here, which is literally like how it's going to look like on your phone, how your app is going to look like, a component screen where you can kind of see different screens that you've set up and how it all flows together, and then properties, which can help you control the specifics of different elements that you add onto your screen. And if this doesn't make sense right now, don't worry, it'll get a lot simpler later on, but this is just how it's going to look like big picture. So just to dive in a little bit more specifically on what the different parts are, like I talked about the big four on the design mode of App Inventor, but the first of those elements is the palette. And this is where you will find components to insert into your design of your app. As you can see here again, look at all the different things that you can drag and drop onto your app. You can add buttons, checkboxes, date pickers, like For example, like if you want to make like a birthday selector app or a birthday reminder app, you could use a date picker, and then someone could pick the date, and you can use that in your app itself. Images, labels, list pickers, list views, all of these different elements right here that you can add onto your app. An important distinction though is that some of these elements are going to be visible. So some of them are literally like buttons or switches, which obviously the user is going to be able to see. But then some of these are non-visible. So there's like device sensors and online databases and internet connectivity things that the user is not going to be able to see. And when we explore a little bit on MIT App Inventor, you'll see that it's going to be on your component side of the developer mode, but it's not actually going to be on your main screen. And so these are the different elements that are in your palette. And the best way to learn about what's in the palette is just to explore with it. And we'll do that in later lessons, of course. Next is your viewer. And this is probably the most important, in my opinion, of the developer mode, because you see and you can view components as they would appear on your screen. So as you can see, you see your phone size right here. And that is just like the dimensions of your screen. So pixel by pixel. Where the top left corner is 0, 0. And with this, you can also choose what components from the palette you want to hide or show. And you can also modify the screen, so you can work with bigger screens, like simulating how it would look like, your app would look like on a tablet, or different things like that. And you can also see your non-visible components of your app on the bottom. It will show, like, for example, one of the examples I gave was an accelerometer, which can detect whether your phone is moving. That you're not going to be able to see your accelerometer on the phone screen exactly, but on the bottom, you'll see accelerometer sensor. And that's going to be really helpful while developing. Next, we have components and media. So here you can see, like, I would say, like, this is like the blueprint of your app, like the bigger picture of how it looks like across multiple screens. So obviously, any app that you use, it's not going to just have one screen. You know, some of the more complex apps, right? For example, like if you made like a platformer game, you're going to have multiple screens for multiple levels. So in the components and media section, you're going to see the different screens that you've set up, and you're going to be able to navigate between the screens that you've created. And also some of the media elements, like if you upload audio, video, or image files from your computer, you're also going to see this on the components and media side of the developer mode or design mode. All right, next we have properties. And so this is where you can view and edit the properties of a selected component. So like, let's say you drag a button onto your screen. Here you can edit the different, I guess, features or attributes of that button. Like, for example, you can align it to the left, align it to the right, align it vertically, horizontally, you know, whatever you'd like. You can give it a name, give it a color, primary color dark. You can just tinker around with these different qualities. And this is also really useful because a lot of times when you're coding, like you have to, like when you're coding like on a non-drag and drop type program, like programming language like Python or something, you have to define these directly. But for here, you can define them and modify them in the properties, and then you can see how it looks like directly. And so that's a really neat aspect of MIT App Inventor that you guys should take advantage of. And then, so I talked about like developer mode, right? Right after developer mode, then you have blocks mode. And so this is where in blocks mode, you're going to see the actual logic behind your code. Obviously, when you have a button, you can drag and drop your button in developer mode, but you actually want to be able to like do something once the button is clicked. And for that to happen, you need to go into your blocks mode. And blocks mode is where the actual, I guess, magic happens. And you know, this is just essentially what it'll look like. You'll have a lot of built-in commands and programming steps that you can take, but we'll dive into the more specifics later on, and I'll show you how block modes look like in a little bit. And so blocks, like in blocks mode, you're gonna see literally like on the side of your screen, just like developer mode, blocks like this. It's very similar to like how the palette looks like in developer mode. Like you'll have blocks right here, and you'll have control, logic, math, text, lists, dictionaries, colors, variables, and procedures. And all of these are going to be really important when, you know, actually going through the logic of what your program is actually supposed to do. Again, the example I gave was a button click. You would have to actually drag your button physically in developer mode, but in blocks mode, that's what's happening behind the scenes when you click the button. On the bottom left of your screen, you're going to see errors. So MIT App Inventor is really nice because it kind of gives you like warnings or errors beforehand. And the yellow like triangle with the exclamation mark, those are like warnings. So it not necessarily like when you try to run your code, it's going to crash. But it's something that you should probably be attentive of, or something that would cause a logic error or something like that. But the red error is like something that will like, it will actually like your code will not work because of this error. And it'll show you where the warning is and show you kind of what blocks or where in your code the error is. So especially when you're just starting out, like all of you guys, this is going to be really useful to look at. So that's going to be on the bottom left of your blocks mode. Top right is your backpack. This is where you can copy paste code. So what you can essentially do is you can take, like, let's say you wanted to take some of your code from one button to another. You're going to see that, you know, you can't copy and paste this code necessarily, like just by clicking Control C, Control V, if I remember correctly. But you can use your backpack where you drag it into the backpack, you switch your screen, and then you drag out your code from the backpack. So it's like, it's in effect, copy and paste. Then you have your navigation and trash in the bottom right of your blocks viewer. And again, trash, I mean, it's pretty self-explanatory. You can just drag like code you don't want into the trash. The navigation you can use to like zoom in or zoom out. All right, so now we have kind of additional resources. I mean, what I'll go ahead and do is I'll copy, I mean, you can take a picture of this link right here. And go ahead and take a picture of that if you'd like to look into specifics. And there's so many different blocks that we're not going to be able to go through each and every one of them, but this is where all of them are listed. So especially when you're getting into more complex projects and doing some of the bigger projects that we have planned out for you guys later on, you want to look into this library because there's all sorts of, you know, cool commands and logic functions that you can put to your advantage. So yeah. All right, we're not going to do this yet. What we're going to do now is we're going to set up App Inventor, so the App Inventor companion. So what you guys should do real quick is, one second, I will stop sharing for 1 second, and I will ask you guys to go onto MIT App Inventor, and we're going to teach you guys how to set up real quick. So let me give you guys a link in the chat. So go to this link right here, put it into the chat. And so you can go onto this link and just log in. If you don't have an account already, go ahead and set one up real quick. And then also what you want to do is if you want to run your app on your phone, go ahead and download the MIT App Inventor companion. So it's like, this is what it's called on the Play Store. And you need an Android device for this. This is what it's called. So you can download that on the Play Store. Yeah, and then go ahead and log in, and I'll give you guys like maybe like 5 minutes. After 5 minutes, and you can also like private message me if you're having some problems. Alice, you have your hand up. Do you?
Oh yeah. I don't have an Android device, but so can I use like the emulator?
Yeah, you can use the emulator. You can. We're not going to be coding like or like running a lot right now in this first lesson. It's more of just to get you guys exposed to it. But yeah, you can just use the emulator. Yeah.
Oh yeah, thanks.
You can't use the iPhone if you want to run your app on your phone. So yeah, and then the emulator, I'll show you guys where it is. So don't worry about it. Yeah, it would be best if you guys could get access to an Android device for later lessons, but for now, like, don't worry too much about it, but you can just use the emulator, which is like which I'll show you what it is if you don't know what that is. But I'll wait till like 12:35 or so, or 12, yeah, 35 sounds about good, for all of you guys to get kind of settled in and download the needed things. And also, we're gonna take like a 10-minute break at around 1 Central Time, so that's like 11 for you guys in California.
Can I ask, when you download the MIT App Inventor, is it supposed to be like an app, or is it supposed to be in your files? Because I can only see it in the files.
Yeah, so I mean, all you need to do right now is download this A2 companion app, like on the Play Store. If you don't have it, then I mean, don't worry. I mean, maybe I'm not understanding your question. But all you need to do right now is go onto this link, appinventor.mit.edu, and log in, and you should get into a link that looks a little bit like this afterwards. We haven't started, there's no coding yet, so we're just, after you log in, you should get into a link like this.
Rithvik, you are not sharing your screen.
1 second. All right. Okay, so when you log in, you should get into a link like this. Let me know if you haven't yet. I have some other projects. I mean, if you just set up, you shouldn't have these. These are just older projects that I've worked on. But your screen should look like this, right? And so obviously I'm logged into my account. You should have different like things like here. Here you can see your projects. Connecting, which is where the emulator is, which you can't use that yet, but I'll show you. That's where the emulator and all of that gets set up. Then you can see your projects, of course, my projects, and then view trash, as well as guide and then settings, and then help if you need it. There's like some help links, but essentially what you guys can do for now is just go ahead and set up a new project. And to do that, there's 2 ways to do it. There's this button, which makes it super easy. Just click start new project, or you can click projects, then go down here and then click start new projects. So I'll go ahead and just click right there. This is not, we're not going to really be, this is just to show you like how it looks like. So I'm just going to call this like test 1. And you can just create that project. And then once you do that, it should go directly there. Yeah. So it should be like that. So, and again, just please unmute, like if you, and just let me know, like if you need me to help out, or you can obviously message in the chat and Ambrose can help you out. But we went through those slides and now we can see like how it actually looks like. And so again, so there's designer mode and then blocks mode, right? So designer and then blocks is how you switch from like the visual to kind of the code behind the scenes is the best way to describe it. On designer mode, you can see your palette right here. All the different things. So like, just for example, you guys like can see like I can drag in like a switch. I'll just go ahead and drag a button this is just for demonstration, basically. A checkbox, just some random stuff. I'll take a date picker as well. And then as well in the palette, you also have like things like your layout. So you can, if you want to arrange your like screen in a nice orderly way, you can use like these different layouts. So if I just show you, basically like once you get into like uh, let's see, I'll actually delete that, but like a horizontal scroll arrangement. Basically, this will add like a scroll for you automatically, a horizontal scroll. So you need to do that, or you could add like a table arrangement, and then there's things for like media. So if you want to add like a camera button or something like that, a translator. There's all sorts of cool stuff right here. Drawing and animation. So if you want to draw a canvas for like users to be able to like draw in a ball, like just for like games or something like that. Maps right here. Actually, I think later on we're actually going to be doing a map project, so you're obviously going to be using stuff from here. Different sensors. This one is one of my favorite sections. There's accelerometer, barcode scanner built in, barometer, which is like for air pressure, which is really, I don't even know how they got that to work, but clock, gyroscope, I mean hygrometer, which literally tests for like humidity, light, location, magnetic field, closeless, like near field. So proximity, basically like a proximity sensor. There's another one right here, thermometer, pedometer, which is like how many steps, like if you want to make like a pedometer app, as well as orientation. There's all sorts of cool sensors that you can play around with here. There's social, so like different, like if you want to make an app with like, for example, like on different apps, like they have like a social media button, like you can share whatever's content from the app. This is where that would come into handy. There's all sorts of other stuff like database work, connectivity, Firebase, which I don't think we'll be working in just about now, but like Firebase is a cool database that you can store outside through Google. And then if you do like Mindstorm stuff, I've never worked with this myself before, but like Lego Mindstorm's EV3 stuff and sensors that you can connect with to an app. So all sorts of really cool stuff in the palette for you to work with. And of course, then we have the viewer itself. The viewer itself, like this is how, like if I were to simulate this app or emulate this app, this is literally how it would look like on my phone or on the emulator. And here, of course, you can see the different elements. You can click on them. And what you'll notice is when I click on them on the components page, they will start, they'll get highlighted. So for example, like I mentioned earlier, you can also play around with the size of your viewer. So like tablet or a computer monitor size. So this is way bigger, but or like a bigger monitor size rather. So you can also play around with that. And so that's in terms of the viewer. And then we get to the components page right here, where when we click on it, we can see the different screens we've set up, which we've only set up one screen. And then the different components that are within the screen. So I told you guys that we can look at kind of behind the scenes, or like not behind the scenes, but the bigger hierarchy of our code. And so one way to do that is you can actually add a screen. So if I add a different screen, you can do that by clicking this button, add screen here, and giving it a name. You see all of a sudden that we have a different component. We go to a new component, and now I can add different stuff in this screen. And so this stuff won't be on screen 1, but it'll be on screen 2 instead. And I can toggle between those two screens by clicking these two buttons right here. Yeah, so that's how the components page essentially works. And you can also rename different elements. Like if I don't want this to be named checkbox 1 for whatever reason, I can like rename this I can rename this to like cool checkbox. All sorts of different features within App Inventor right here. And then one of the most important features in this designer block is the properties page. So for example, if I want to click on this button here and mess around with it, I can click on the properties and just play around with these different features. So for example, the text alignment, if I don't like it to be centered, I can do left justify. And you guys may have noticed it like move. This button is kind of small, so you can't see it too well, but you can play around with it. I can change the text that's in the button, so I can change it to my name, like name it to like Rithvik's button. Now it's like, it looks like that. I can do the shape, so I can make it oval shaped if I don't like rectangle. You can set an image, so you can make this button literally like an image, like whatever you would like. play around with the font, the color. Let's say my favorite color is blue. I'm wearing a blue t-shirt, so I'll make it blue. Actually, I'll make it closer to the blue on my shirt. So you can just play around with these different properties. And again, when you have time, definitely like while you're working on your different assignments or things like that, definitely try to work and look at the different palette features in the palette, and also the different properties that are linked to those features. Now I'll go ahead and show you the blocks page, and we'll come back to this later a little bit, but the blocks page again, and also how you toggle between those is in the top right, designer blocks. This is how you get between those two. You have the different kind of functions that we kind of mentioned. And what you'll notice is not only do you have the built-in programming, but you also have screen components. So now I have stuff from screen one, like this button. And with that, I can have different events that are linked to the button on the screen. So for example, I have this kind of command right here that's linked to button one. And so that's how, I guess, the connection between what's on the design screen, the designer screen, and then the blocks happens. That's where the linking happens. It's with these different kind of commands that are specific to your elements that are actually on the screen. So like for button, I have like when button one click, do something, or switch one, I have like when switch one is changed, do this. So like when someone actually clicks on the switch, some cool programming can happen. So you have different things like that. And then also you have like the built-in stuff. So I'll go ahead and just trash this for now. You also have like your control section, which is just generic like commands. Save empty screen. So you have like the generic commands like if then statements, which we'll dive into like the specifics of these in just a little bit, but you have all these different like commands and programming blocks that you can use to do more complicated things once like a button is clicked or a switch is clicked. So that adds into the interactivity, the interactive nature of your apps, or like the different more complex functionalities that you can add in through App Inventor. Then you have like colors, lists that you can make. Like lists are basically like a sequence of different words, or text, like if you want to add like a specific text, like for example, like when a button is clicked, your code could print out or change a text box into a specific sentence, stuff like that. And then as well as variables. And we'll dive into what these are in a little bit, but this is where all the built-in commands are. And these are the ones that are linked to a specific screen. And if you want something from screen 2, all you do is change this to screen 2, and then you see the different elements that are linked to screen 2. So it's that simple. And then here are like the warnings that we talked about. I said this in bottom left. So if I do something like problematic, it will show me the warnings, and these numbers will obviously change. And then I can zoom in or zoom out with the navigation tool here. And then the backpack, which I'll just show you guys real quick. So I can drag something into the backpack, and then it's in the backpack. Wait. And once I get into the backpack, I can basically just access it later on. So it's like it just stores your basic command. So that's something that you can use there. All right, so I'm going to go ahead and stop sharing my screen here, and we'll get back to this later. But yeah. All right, so I'll give you guys maybe like 1 or 2 minutes just to like mess around with App Inventor. I know like it's like you can just look through the different commands and things. I may have gone through it a little bit quickly, so if you have any problems with it, just let me know. And oh yeah, whoops, 1 second. I also have to share one more thing. Sorry about that, which is the emulator. I know one of you guys asked about the emulator. So basically, when you want to run your actual code, to do that, you have to use this connect screen right here. And so for the connect screen, basically what you're going to see is you have basically 3 options. The AI Companion, which is the app that I talked about, which you can download on the Play Store. You need an Android device to use it. the emulator, as well as USB. So USB, you can just like physically like plug in your phone into your laptop and or monitor or whatever you like are using, and you can run it directly. But some of you guys asked about the emulator. So when you want to run your code, you can just click on emulator and it should work directly. For the AI companion, what actually happens here is pretty interesting. So it'll give you like a QR code. Then you go onto your actual app itself. You guys don't use this code. You guys will have a different code than me. But what you do is essentially you go onto the app, and then I don't know how I can show you, but if you're on the app, what you'll see is you have space to connect with a 6-character code. So you can either put in this code itself, or there's a built-in QR code scanner within the app where you scan this, and then your phone, which has the App Inventor companion, and your device, your laptop, are connected, are in sync. So now you can run your code onto your app. So go ahead and you can also try doing that. Right now your app will probably just be a blank screen, but still it will be connected. So go ahead and try doing that, and let us know if you need any help with the connecting. So go ahead and try that and let us know how it goes. If you have any questions, just let us know in the chat, and I'll try to help you out. And Ambrose can also help answer questions. So what is your error, Russell? Could you like type it out? Like, what do you mean? Like, is it saying, is it giving you an error message?
It says like unable to retrieve. It's like unable to retrieve the version or something like that.
Unable to retrieve. Could you repeat that 1 second? Sorry, couldn't hear you.
Like the thing flashes really quick, so I can't really see it. It says unable to retrieve version of AI starter installed in on your computer, and then the connection will proceed, but yeah.
Okay.
If,
Funny enough, I got that same error.
not sure if it's because I use like a Linux computer, but like.
Oh, that possibly could be why. I'm trying to look. I don't know off the top of my head how to fix that error. Do you have a Android device?
No.
Okay, go ahead and look into this. Actually, I think you might need to download a setup software. Okay, my bad. If you want to use the emulator, you have to forgot this step. You have to go and click on follow the steps in this link. You just have to download like the AI starter tool, and so you should be able to use the emulator afterwards. So
Okay.
that link, if you want to use the emulator. If not, you can just use the USB or direct. So I'll give you guys again a few minutes to go through that link, and then just like give me a private message when you're ready to move on. Again, like give me a private message when you think you're ready, or if you need help. If you need help, you can put that in the public, but. Yeah, Catherine brings up a good point. You need to set your screen timeout to probably never, or a good enough time, because like when you try to connect your phone to or using the App Inventor companion, it's a little finicky, which is why I like to use the emulator. But um, obviously, if you want to like show your app to others, you people are not walking around with the emulator, so just like mess around with your screen timeout so that it doesn't disconnect your phone from your computer. Okay, so only one person has messaged me that they are ready, but obviously I'll give you guys some time, you know. Um, or actually, like instead of, I think that might be a little tedious to like message everyone. So like, um, I'll just wait for like, hmm, let's see what I can do. So I think basically right now what I'll do is I'll just start off with the break right now itself. It's like 12:52. Go ahead and like we'll get back at like 105-ish, 102, 103 or something like that. Um, in that extra kind of time you can use to like tinker around with MIT App Inventor, or just take a break, and we'll get started at around 102. So see you guys then.
Rithvik, I have a question, really quick.
Yeah.
Yeah, so I don't know if you have an Outlook email app on your phone, but for some reason, I'm only limited to a 5-minute screen time where it's awake, and then after 5 minutes, it just shuts down automatically. And it says that Outlook email app is the reason that's I can't put it to never. So I don't know if that's the same experience for you since you're in college.
Yeah, I don't have Outlook on my phone, so but I'm trying to look on my phone and see. Yeah, that's odd. I mean, the only thing the only thing I could recommend doing is either, I mean, of course you could try another device that doesn't have Outlook installed, or just like maybe like see the settings of Outlook, go to the settings, and then just like see if you can disable like the notifications for Outlook and see if that helps. But I don't know too much. I can try looking online. Yeah. Oh, Catherine, try like messaging, private messaging, like more details to like Ambrose maybe, and he can maybe try helping you out during the,
Gotcha.
just like by looking at the internet, because I don't know the answer off the top of my head. So yeah. All right, and welcome back, everyone. I think most people have joined back again. We're gonna go ahead and just really just finish up the slides. Obviously, you guys have gotten exposed to App Inventor, which is great. It seems like a lot of you guys have gotten pretty familiar, and some of you even gotten your emulators and AI companion apps working, which is really neat. So let's go ahead and let me go ahead and share my screen with you guys again. So. Um, so now, obviously, we went through App Inventor a little bit, and we found some specifics in terms of how we could look at a screen element, an element on this screen, and link it back to the code in the blocks portion of MIT App Inventor. And so the way you do that is you have an object, and the object is like your button, or something of it's an instance of a class basically, or an instance of a type, if you want to get technical. But essentially, like this button one is like an object of a button, the button type. If you want to think of it in a little bit more technical sense. But essentially what we're able to do with an event handler is this defines like how the app should respond to certain actions. So what should I do once the button is clicked? What should I do once the button is maybe held? App Inventor has different pre-built blocks for these different events. And so you'll see like in this kind of snippet right here, we have the object, which is again the button, the specific button that we're trying to indicate. So button one, if you have like a second button, button two, button three, you have to specify which button you want this event handler to work for or be applied to. And then the event. So for buttons, if I don't remember off the top of my head, like the specific events that are pre-built, but obviously when a button is clicked, that's like basically like the main thing that a button handler or event handler for a button should do. Other examples are like when a checkbox is checked, like that could be an event, or when the accelerometer is like the event could be like when it senses a change or something like that. And then what should we do? What should the program do? What should the logic behind it be? Or what needs to happen once the button is clicked? That's what the event handler is set up to do. So you see like right here we see set we want to set this text label to hello world. So essentially what's actually happening right here is when the button is clicked, then the event handler, the event handler is kind of activated. There's probably a better word for it, and then the do of this event handler is processed, and that changes the set label or the label to hello world. And so that's essentially what you want to do if you want, I guess, something to happen once an object is manipulated or something is done in terms of user input for your code. Next, as you can see here, we have the event handler, which is like this yellow thing, yellow block of code. But in between right there, we have a command statement or a command or expression. And so this determines the action to be performed. So what should actually happen? So again, the event handler is like if something happens, and then the command or expression is what should we do, right? And so the expressions denote or generate a value that is assigned to the command. So the command is what happens, so what should the program do? And then the expression is kind of a value that is important for the command. So the command in this part is the green section of this code block, where the command is telling us, okay, we need to set the label to something. And then what should we set it to? We set it to this expression, which is in the pink, which is this hello world string. And so all of these different sections, expressions you can get from the built-in section of the block portion of MIT App Inventor. And then these commands, you get them from, as I showed you before, like on your block viewer on the blocks part of MIT App Inventor. For different elements of your screen, you'll have these kind of commands already set up by App Inventor. So you need to drag one of those, and then you drag in the corresponding expression to do what you want to do. Slide. All right, so now we also can do like object properties. So this links back to the property section of the design mode. So properties you can manipulate not only in the design mode, but also in the program or the blocks mode. So if I have a button on the screen, or if I have the screen background color, I can not only set it directly, like on my own. If I want to set it directly in the design section, I can go to the design mode and then just play around with this primary color right here, or I mean, this background color right here, and change it to blue. And the screen will just be blue. But what if I want to do it after a button is clicked, for example? That you have to do in the blocks part with an event handler. So what you would do is, like, if screen 1 is clicked, then we have to call this command right here, which sets the screen 1, the background color of screen 1, to this desired property, which is blue. So as you can see here, we have the object, which is screen 1, which is like the background of screen 1. And then the property, which is the background color of screen 1. And then we set it to an expression or some sort of property, desired property, which in this case is the color blue. Next, we have variables. I'm sure all of you have done like something with variables in the context of math before. And in programming, it's like the same way. It's a label or storage of a. Variables are used to store and label data in reference to a program. So in this problem, for example, or in this line of code, we initialize a variable which we've named myvar. And this myvar can be any sort of value that we assign to it, and it can be changed. And what's convenient about this is, instead of typing the same section hello or over and over again, we just have a variable called myvar, and we can just call that whenever we'd like, and that would just be equivalent to the value hello. And using variables can just not only make your code much easier, to read in terms of readability, and for others to look at and see, what you're trying to do with your code, but more importantly, it's really easy to modify a lot of values at once. So instead of changing a value, changing the word hello for every single section that myvar is in, we just change this assignment once, and then all of those values are changed. And I'll show you a more specific example later along the lines. And you'll be using variables plenty of times in your projects. I'm sure you will. So you'll get the hang of variables for sure. So not only do you need to initialize, which is like creating your variable with this command right here, but you can also retrieve and assign values. So these are called getters and setters. So, or get or set methods. So you can get the variable. So if you want to get like, what is the value of my variable, you can use this command right here to retrieve that value. Or if you want to change it from, let's say, if you don't like hello, you want to change it to like hello world instead, you can set global my variable to another value, like an expression with a different set of text, for example. So that's how variables work. And then there are different types of variables, right? So in terms of types of variables, there's math. So you can have like a constant or something like that as a variable. You can have text, like a string of characters, or Boolean, which is like true or false. And in terms of, those are the specific types of variables, but there's also different scopes of variables. So in terms of scopes, there's global variables that anywhere, like can be accessed anywhere in the screen. But there's also what are called local variables that can only be defined or declared, passed, or really accessed in your specific functions and for specific commands. These blocks of code are a little bit hard to see, but basically, if you want to know if your variable is global or local, you can just look right here and see global or local. And again, local is specific to specific functions. So the difference really is who can look at what that variable is. So global variables anywhere on the screen, any function, anything in that block of code, and anything in your code for that specific screen, anyone can look at what that variable is. But for local, it can only be accessed within that specific function. So for example, for here, like, wait one second, I define this local variable height. If I defined it for a specific function, if I wanted to access height outside of that function, I wouldn't be able to do that because it's a local variable. So you'll see where this comes to use later on the line, but this is just to give you an idea on what the types of variables you'll be working with are. Now, all of you, I'm sure, are familiar with basic math operations, and you're going to be needing these in some of your code. So you can do addition, multiplication, subtraction, and division, and definitely more than this, I believe. Like you can combine multiple operations together to form, things like exponents or something like that, exponentiation. So this will be in the built-in math operation tab on your blocks mode in MIT App Inventor. And so you'll be able to use this to your advantage, not only by like manipulating variables, but just simple addition or multiplication, wherever you would need it in your code. Now, order is important. So blocks, you can think of blocks as like parentheses. So I'm not sure how well you can see this, but like basically like blocks are like a set of parentheses. So you have to keep that in mind when you're working with these different math operators. So for example, here, there's a little block for the division that happens inside of this larger addition. So that means that this inner division will happen first. So right away, I'll do this 6 divided by 2 first, and then I'll go into the bigger addition step. Another example is right here, where you see the division is actually now on the outside of this block of code, but the addition is on the inside. So the addition will happen first, and then the bigger division will happen later. So keep that in mind. Sometimes you'll be like manipulating your code, and then you'll like be wondering why like the addition, like why is MIT App Inventor doing like basic math wrong? But it's actually like just the parentheses and order of operations. So keep that in mind. And then also like commands in a command block are carried out in order from top to bottom. So when we do this right here, like this snippet right here of code, goodbye is like the last set. So that would be like what is the label of what the text for label 1 is at the end. So it happens from top to bottom. So remember that. So sometimes you may have changed your variables, and whatever's the latest assignment is what is going to be used. Once you change the assignment, your previous assignment is kind of gone. So keep that in mind, like when you're working with your code. All right, so now let's think about like bigger picture when you're working with event handlers. So when you're designing your app, right? Let's imagine like you're designing an app that you want to click a button and then your screen turns a different color, like we talked about earlier. So the way this works is you would drag from design mode, you would drag a button to your screen. You would center it, align it, do all of those things. Obviously, like they changed the text right here, if you can see, like to background to blue. And they just customized it and did all of that stuff just to get it ready. And that's just in the design mode. So if you had just left it as that, there would be a button on your screen. If the user tries to download your app or use the emulator or something, you click on the button, nothing happens because all you've done is drag the button on design mode. You need the blocks behind the scenes in order to make everything work. So to do that, that's where this code comes in the design or in the blocks mode of MIT App Inventor. So what you see right here is we have an event handler like we talked about in yellow. And so when button one, so when this button right here is clicked, we set screen one, the background color, this property of screen one, to our desired property right here, which is the color blue. And this is something like if you have MIT App Inventor open, you can easily try to implement this. All you do is drag and drop these different components, and then you're able to make your screen blue. And so that's just a simple, probably the basic example, most basic example of an event handler, but it's super effective. When a button is clicked, what happens? Our screen turns blue. All right, so now we're going to go to a different slideshow. One second. And if you have any questions, please feel free to put in the chat. But now we're going to go into a little bit more specifics on some of the logic operators and things like that of MIT App Inventor. So let's go ahead and share my screen. All right, you should be able to see this now. And so we had talked about kind of the event handler. Now we're going to talk about logic, and logic is going to be super useful also for all of your code. And this is something that you guys will pick up pretty fast. It's stuff that you think about when you're doing an app, but computers take things very literally. So you have to actually code in different, responses, I guess, to user input, and that you can do with logic. And it's super simple, and you can just use some of the basic inbuilt functions in MIT App Inventor and create more complex apps. So again, just real quickly to recap, we have event handlers. So these do things when buttons are clicked or they respond to some sort of user input. So that's what event handlers do. And again, remember, commands execute in order. So once we set this last label, the computer doesn't remember that we set it to, or I guess the computer doesn't really, there's no like kind of evidence that we set it to how are you earlier besides looking at this code. Once you change this label, it's changed. It's not gonna, you can't really undo it besides just reassigning it back to how are you. So just remember that. And then these are all like kind of the, these are called expressions, what's in pink. Button one is an object. Once you, later along the line, when you get into like object-oriented programming, this will make a lot more sense. And then these are commands. Commands are doing things, telling labels to change or doing things like that. And then the event right here, which is the important thing that the user kind of does. This is what the user does, this event. And then math, again, order of operations, remember that again. And then variables, global access anywhere in the program, not just, and I said earlier in the screen, actually it's anywhere in the program. Local is accessed only in a function that you declare. And then you have math, text, and Boolean. All right, so now let's get into logic. So we talked about the types of variables earlier. We talked about math, string, and logic, or math, string, and Booleans. Booleans are super important for logic. I would say like Booleans are the key data type for logic, because if you think about it, Booleans are an event or something. If something in logic has to be either kind of true or false, And so based on true or false, your program can branch into different activities. And so Booleans is a binary variable type that's either true or false. And Boolean expressions, they can use different operators to equate to true or false. For example, like if I want to say, okay, the user, like if the user clicks my button 3 times, or I count the number of times the user clicks a button, if that's equal to 3, then it should return true. If not, then it should return false. So these play a big role in what's called control flow, which we'll get into a little bit later, and conditional statements and iteration. And so I think an easier way to do this is to just show you. So right here, we see an example of a logic comparison. So what we're able to do is because able to compare different objects. So we're able to compare, let's, for example, like among numbers, are numbers equal? Are strings equal? So are like literal text segments, are they equal? Are different Booleans equal? As well as our lists or dictionaries or other objects, are they equal? And with that, we're able to use the inbuilt Boolean function and able to return these different operators. In Booleans also, of course, we can use like math operators like equality, so like equal to or not equal to, as well as size. Is something less than something, greater than something, greater than or equal to, less than or equal to. We can use all of those different operators, and it will just return us whether it's false, false, or false or true. Now, strings are a little bit interesting. What Boolean operators do, like you guys would have seen like less than or equal to in a math context several times before. But what we can also do with in MIT App Inventor is we can actually compare text using the less than or equal to. And this isn't as intuitive as you would think. Like how do you compare like 2 different strings? And the answer to that is that we do this based on alphabetical order. So what comes alphabetically is kind of bigger than what comes before alphabetically. So obviously Bob is greater or comes after Alice alphabetically because B is after A in the alphabet. And so that would return true. But also, like if I did Alice, compare text Alice greater than Bob, that's not necessarily, that's false because Alice is not after Bob in the alphabet. And that's this math operator, you can't just use what the inbuilt math function for this. You have to use the compare text functions, but it's still that same symbol and somewhat similar in logic in terms of what the math operator, which we're much more familiar with, of less than or equal to, less than, greater than, or equal to. And obviously, of course, we can compare text. And I would say like for strings, like most of the time you're going to be using just equal to or not equal to. And in this case, we're asking, is Carol not equal to Carol? Spelt exactly the same, all capitalized the same. That's obviously false because they are equal. And so this is very intuitive, and I'm sure you guys understand this, and you can use this in your code, and we'll show you an example of that. Now, some of you guys may not know exactly how Boolean expressions work. And so Boolean expressions are, Booleans are more than just true or false. You can also do kind of expressions that are a little bit more complex between true or false, and kind of operations or expressions between the two. So the 2 big ones, or the 3 big ones that you're going to see, are not, and or. So not is basically, it just is the opposite of what it is. So if I do the function not true, like this right here, not true, that will equate to false. If I did not false, then that will equate to true. Very simple. The and or are a little bit more complicated. For and, this is what I would say. And is, it evaluates a true if both inputs are true. Otherwise, it's false. So if there is a false, but in any of these things, it's automatically false. The only way that and will equate to true is if both inputs are true. So if it's true and true, then it'll equate to true. But if it's false, then if there's a false in there, it doesn't matter if it's true, false, false, true, false, false, it will all equate to false. For or, it's, if anything is, it's kind of the opposite in the sense of and, where if anything is true, if any of the 2 are true, then it will equate to true. So the only way that or would equate to false is if it's false or false. That would equate to false. If either of them are true, then it would equate to true. So if at least one input is true, it will equate to true. And this, you might be asking yourself, like, why would I even need to use this? There's actually many different aspects that you can use this when it comes to control flow in your programs. And again, we'll talk about that in a little bit. All right, so this is where control flow really happens, which is an if statement, an if-then statement to be more precise. And so this if-then is inbuilt in MIT App Inventor. You can find it in the built-in functions and blocks mode in MIT App Inventor. Essentially, this is a conditional. And what a conditional is like, essentially, for example, like when you go to an amusement park, like if I want to explain like an if statement, basically, when you go to an amusement park, you always see like a sign for like certain rides, like you have to be this tall to ride, go onto the ride, because you don't want like a 2-month-old to be going on like the Titan at Six Flags or something. So the idea behind it is, if someone is greater than the height, then you do something. If someone is less than the height, then you do something. It's similar to that in programming. If a user does something, then I want my program to execute certain tasks. But if they don't do something, then I also want my program to execute certain tasks. So in this situation, if the global variable x is equal to 0 and the global variable y is equal to 0, then I want to do this certain task. So if this condition, the if condition, is not met, if after I do all these kind of calculations, if they're equal to, if it's false, then I won't execute this then statement. This would only execute if it's true. So using this conditional, you can control the flow of your program and set branches on where your program is going. Obviously, this is just an if statement, and I would say a lot of times you won't be using just an if statement. You're going to be doing an if-else statement, because in an if statement, if this is not true, if this condition right here in the if is not true, nothing happens. But if it's false, then, if it's true, then the then statement happens. But if it's false, nothing happens at all. So you definitely want to handle like the else case as well. And that's where the else statement comes in, where now if this condition is not true, I also have a plan in mind in my program. I'm going to set, instead of 5 and 3, I'm going to set x to 0 and then y to 0. And this executes if the if statement is false. There's also what's called an else if statement. And an else if statement is, I guess the way I would describe it is, it's like another test before you go to the final else. So the flow of this program is, okay, is this condition true? If it's true, then I do this then statement. None of this other stuff gets executed. Nothing below this then statement gets executed. Let's say I check if it's true. If it's not true, then I check this else if statement, and I check if this condition is true. If this condition is true, then I do my then statement and I ignore this final else. Then the final flow is, okay, let's check my if statement. It's false. Then I go to my else if statement. I also find out that this is also false. Then I hop over to my else statement, and then I have to do this, whatever is here. And so, as you can see, these are the different, I guess, what I said. This is just that in text format. When conditional 1 is true, we do this. When 1 is false and 2 is true, we do this. And when everything is false, all the different conditionals before are false, then we do this. All right, so I kind of talked about the amusement park analogy. This is kind of similar in a sense. Like, I want to check if an inputted age is preteen, teenager, or adult, and I have these different conditions in place. So I set the age to 15. So I want to check in my program whether a 15-year-old is a preteen, teenager, or adult. So the first thing I check is this person younger than 15? That's my first if. And 15 is not younger than 12, so this doesn't get executed. So we go to our else if. Then for my else if, okay, I see, is 15 greater than 12 in this inner if greater than or equal to? Yes, a 15-year-old is greater than 12, so that's true. Then I checked what's on the right side of this and. Is a 15-year-old less than 18? Yes, a 15-year-old is less than 18. So we have true and true. True and true, if you remember our Boolean expressions of what we talked about earlier, true and true means that together the output of that is true. So since the else if is true, then we set the global type to teenager. And so we're able to see that a 15-year-old is a teenager. We don't execute this final else because this else if condition was satisfied. Now there's also something called nesting if statements. So sometimes you want to check one condition and then you want to check another condition within that condition. And so that the way it looks like is basically like this. Again, some of these drag and drops, they look complicated. Partially it's because like there's a lot of colors, but it's not that complicated. All it is just checking a condition, then checking it. If that condition is true, then we want to check another condition. If the outer condition is not true, then we're not even going to check this inner condition. We just exit the if statement. And with that, again, we're able to check, I guess, a condition twice. And this nested if statement is a good alternative if sometimes it's hard for you to kind of wrap your head around Boolean expressions. You can just do this instead of doing a large if statement check where you check, okay, I check this condition and this condition. Instead of that, I can just check the bigger condition. Then within that condition, I check another condition. It's a nice alternative. All right. So again, in your program, you're going to be using inputs. And part of this is like you have to initialize values to different things. So for example, here I initialize a global variable age to 15. I initialize the rating to R. And another example right here is this is an example of initializing or creating these inputs for my if statement. So you typically, when you have an if statement, you need to have some sort of input or some sort of value in that is a variable because you want to be able to check it. If you know what the variable is, then I don't see the point necessarily of having if statement because you already know what it is. So you don't need to like just check different ways. It's almost as if like you go like you had a bunch of like teenagers that are all the exact same height that go to an amusement park. You wouldn't necessarily need the sign like if they're tall enough to ride because like you already know like all their heights, and so there's no variability between them. It's kind of similar in this. So I would say like even this statement right here, like this if statement is a little redundant if you think about it. So rather you would want some sort of variable input that you can now check in your if statement because now you don't know what the value is going to be. So you actually need an if statement to check all the different possibilities. And then obviously your program is going to output something. So at the end of the if statement, you want your program to do something about it. So you've gone through all the different control flow. Now what's the output at the end? That's where that comes in. And I guess we're not going to necessarily work on this project right now, but something that you can maybe think about, like a really good example of using if statement is this type of program where you can use a movie ticket, make a movie ticket app on MIT App Inventor, where you put in like your age and then the program you put in the rating maybe of the movie and the program will output whether you're allowed to go to that movie. So if I put in my age as like 8 and I put in rated G, the program can output yes, and that can be done with a simple if statement and then some simple interactive components on your main screen. But if I inputted like 10 years old and I put rated R, then the program would output like you can't go to this movie. It's a simple example and application of if statements. I think we need any of this right now. So what I'm going to do right now, before I go to the third set of slides, is I'm going to ask if anyone has any questions about if statements beforehand. If statements, else statements, anything like that before we go on to the final slide of slides. Anyone have any questions about if statements? You can private message me if you'd also like, or you can just put it publicly. It doesn't really matter. Up to you. Okay, if nobody has any questions, then we're going to go to the final set of what we'll be doing. So let me share my slides. So this one, we're just going to talk about a little bit of the basics of data types. And we're going to recap a little bit again about else statements. Actually, these original lectures were designed for multiple days, but we're going through things a lot faster. And again, if I'm going too fast, just please like unmute or go into the chat. Obviously, I don't want to overwhelm anyone, but I'm sure you guys are getting it. So we're going to go ahead and keep going. So again, remember these Boolean expressions. The not negates whatever you have originally. The and, it checks like whether both inputs are true. The or checks if whether any of the inputs are true. And with that, you can control the flow of your programs and decide what you want to do with a variable input. You have logic comparisons where you can use to evaluate or compare two different objects or two different inputs. And with that, it'll give you evaluate that out to a certain response or Boolean output. So whether it's true or false. All of Booleans are just Boolean is a binary data type. So all the options are either true or false, which is amazing with how much stuff you can just do with those. And then simple expressions or Boolean expressions. And then finally, we have if statements, if then else. If statements check for a condition. If the condition is true, then it does a then. It does whatever is in the command in the then part of the if statement. And then there's also else, which if the original if condition is not true, then it'll do whatever's in the else statement. There's also else if statements, which kind of checks for another condition value before it goes to that final else. And the flow of that is like this. All right, so now let's get into different data types. And we kind of touched on this a little bit, but again, the fundamental reason why we're doing this is you're going to have the programming backbone to enter in and start building your own projects, right? And so for that, you need to understand the different data types and what you can and cannot do with them. And first and foremost, what are data types? These are ways of differentiating data, right? It's like, strings and Booleans are pretty different, right? So it wouldn't be, if we just said, oh, these are the same type of programs, then, or these are the same types of data, that's not true, right? So like how we distinguish between the different types of data or different objects in our lives, computers also do the same thing. And in MIT App Inventor, it's really neat because those different data types have different colors, like integers or math stuff has a blue color, like strings have a kind of like this pinkish purplish color, and then Booleans have this green color. And each type has a different role and rule. And each variable must be assigned to a different data type. In some programming languages, like you can have like data that's not of any type, not in MIT App Inventor. If you define a variable, you have to kind of say explicitly, okay, this is a string. Okay, this is an integer. Okay, this is a Boolean. You need to make that distinction. So just to quickly review Boolean, Booleans are true or false. It's a binary data type. There's only two possibilities. And Boolean expressions allow for comparisons. And their primary reason or primarily why you want to use them is for logic and control flow. You don't want to use Booleans like if you were like trying to solve like a physics or like solve like a math problem necessarily. You wouldn't need a Boolean for that. But you would need a Boolean if you want to check if the math problem's answer is what you expected. There's also numeric data types. So in MIT App Inventor, it's just called like a number value. It's just called a numeric data type. And these are for math calculations and counting. If some of you have worked with other programming languages before, you're going to see like there's more specifications of like saying the word, okay, it's a number is pretty vague, but that's how it's defined in MIT App Inventor. In other programming languages, you have like integers, which are like whole numbers, or floating with floating point values, which are like decimals or long data types or stuff like that. But in MIT App Inventor, you don't have that specific distinction. And then you also have like different calculations like addition, subtraction, multiplication, and division. All right, so now we have math operations. So I think I talked to you guys a little bit about earlier that you can combine like these kind of primitive type of operations, but there's also kind of bigger ones that are really useful actually when you do more complicated programs. So you have the square root, absolute value, which if you guys don't know, like that's the way you can think of it is like the distance between a number and 0 on the number line. So it's the magnitude of that distance. So if it's a negative number, the negative number just gets turned to a positive number, basically. In theory, and positive numbers saying the same. There's also min and max, which finds the smallest number within a given number, set of numbers, as well as max, which finds the largest number within a given set of numbers. There's rounding. I think you guys probably know how rounding works, but basically like rounding basically looks at a given kind of decimal number usually, and then like rounds that up to the nearest, rounds that down or up to the nearest whole number. There's different conventions for rounding. The rounding in MIT App Inventor, the way it works is, okay, if you have an even integer starting off, but your decimal point is 5 or greater, then you round up. If you have an odd integer and then in a decimal number 5 or 5 or greater, or 10th value or whatever you're trying to round to, 10th value 5 or greater, then that rounds down. And some of you might not be used to this. You might be expecting this 3.5 to round up to 4, but sometimes in programming that rounding works a little bit differently. And if the tens place is like lower than 5, like if it's from 0 to 4, then it just rounds down automatically, regardless of if it's even or odd. Floor and ceiling are better ways to use rounding, actually, if you really think about it. Like, so floor, basically, it just rounds up regardless. So even no matter what the tens place is, as long as it's anything kind of greater than 0, it's going to round, or floor is going to, or the ceiling is going to round up if it's anything greater than 0. Floor is going to round down if it's anything less than like the number itself. So if you're thinking about like 5.0 to 6.0, if it's anything from 5.0 to 5.9, if you take the floor of that, it's going to round down to 5. If it's a ceiling, 5.0 to 5, if it's anything from 5.001 or something, all the way up to 6.0, it's going to round up. So that's where floor and ceiling can come into use for you guys. Now, super useful function in math is adding random numbers, so random number generators. So this is just like a built-in function in MIT App Inventor. So you can set upper and lower bounds, and then the program will just pick a random number for you within that range. And you can also pick a random fraction, so pick a random decimal number between 0 and 1. So it has to be exclusively between 0 and 1. And then you can like add whatever integer you want to that. But the random function itself, or the random fraction itself, only works within 0 and 1. And you can generate a random number with decimals using this kind of sequence of code right here. So we talked about Booleans, we talked about numerics. Now we have to talk about text, which is kind of like the third of the big 3 types of data. This is a sequence of characters, and this you can use and process and display words and text. It's called a string in other languages. I may have called it a string because I'm so used to calling it like strings in other languages, but it's called a text, I think, in MIT App Inventor. And this is where you can, type out different things like hello or lesson 3 or your name or something like that. That's where you have to do that in text. You can't type out your name as a numeric data type. It has to be as a string of or sequence of characters. And then there's these different functions that you see right here. Like you can find the length of a text, like how many characters are in that text. You can trim the text, so eliminate extra white space. You can check if the text contains different substrings. You can compare text like we talked about earlier. You can concatenate text, which means you can join different smaller expressions together. And then you can also segment off or splice the text. So if you want to just take like the first character to the 5th character, you can use this function right here, which is like segments. And I will say that all of these are just different just like block code formats of functions that exist in other programming languages. So that's why MIT App Inventor is such a great stepping stone into learning other kind of beyond like just actual typing programming languages beyond drag and drop. So if you think about it, what makes a piece of text? Basically, these are a sequence of characters. So basically, like each of these texts will, like, you can type the letter A, grocery store, a bigger sentence. And what you're going to see is that each character in the string is in order is going to be given an index. So in this like segment of words like grocery store, this is how the indices would be assigned, right? So the first one is 1, 2, 3, 4, 5, 6, 7. The white space, interestingly, is also counted, so that's also counted as 8, then 9, 10, 11, 12, 13. So if I said I wanted from 2 to 4, like the indices from, I wanted to take a segment, then the program would start at 2, which is the letter R, and then go to the 4th index, which is the letter C, and then get everything in between. An important distinction to make is that the first character always has an index of 1. If you worked with other programming languages, it usually starts off as 0, but I guess to make it a little bit easier and easier to wrap your head around, the first character always starts with 1 in MIT App Inventor. Then there's basic text operations. Like I talked about earlier, I kind of explained some of them to you already. These are self-explanatory. Length gives you how many characters are in the text, including white space. Is empty, it checks if a text is empty and then returns a Boolean value, true or false. So if I did is empty on like a blank, obviously it's going to return true because of course it's empty. But if I had like anything in between, like if I had like A, B, C, or C, D, E in this thing, is empty would return false. Trim, like I said, it removes extra white space. So you see all this extra white space is just cut off, and that's really useful in certain, especially when you're getting a user input. You don't want to store that extra white space, so you want to use trim, and then it'll trim off that the white space on the outer parts of the text. Notice right here, the white space within the text, or like the different spaces within the text didn't get removed. Just the ones that stop on the outside got removed. So keep that in mind when you use these basic text operations. You can join text. Joining text, it does this without a delimiter. So a delimiter is like a boundary. So it's literally just going to directly join the text. It's not going to add a little space in between when you use this join function. So notice here, it didn't say it's so hot space dogs are running in the park. It said it just combined them directly. There's no space in between. It just started right away. It said it's so hot dogs are running in the park. So you have to keep that in mind. Ways to get around this is to add extra white space at the start or beginning of the text, just to add that kind of delimiter directly. You can also join together numbers with this joining text, and you can also go between numbers and strings pretty easily if you use this join command right here. And it'll, as you can see right here, this calculated 15 times 3, which is 45. Then it did the second part of this join, which was 21 minus 6, 16, which is 5. And then it joined the two together and formed it as a string. So 4, 5, 5. And again, this is different from the plus operation in mathematics. So it didn't output 50 right here. It just literally combined the two together like text. Yeah. And this is a perfect example of what I was saying there. And then finally, we'll get into splitting text, which I talked about a little bit earlier, but again, it looks at the indices and then gets back whatever in the defined range that you give it. So here we said grocery store, we want to start at index 9, which is this S right here, and we want a length of 5. So we get 1, 2, 3, 4, 5, and return the word store back. This is called a substring in other programming languages. Then we can also compare text. Comparing text is, we talked a little bit about this earlier, but this basically is alphabetical. So whichever comes alphabetically is what is considered after when you're using like the less than or greater than symbol, or equal. Equal is, it just checks if it's equivalent, and it is case sensitive, right? So capital letters, this is false because this A is not capitalized. So you also have to keep that in mind when you're working with this. And also remember that capital letters are assigned a smaller value. So when we're comparing the same word, but like one letter is capitalized, the one with the smaller value is the one which has the capital letter. So keep that in mind when you're doing stuff with comparing text. And all of this outputs back false or true, which is like Boolean values. Now, if you want to uppercase or lowercase everything, you have the upcase and downcase functions. And you can use that to change text into the same syntax and get everything into a nice and uniform format. Next, we have searching for text. This checks if the text contains a piece of text. So again, all of these are really self-explanatory, but essentially look like if we have the sentence, Kevin is watching TV shows, if we want to check if it contains the substring or the word is, this function can do it for us. And of course, we see the word is right here, so it's going to output true. We can also check if the text contains a piece of text and return the index of the first appearance of that piece in text. So if we want to not only check, okay, is the word is in that sentence, we also want to check where is it in that sentence if it is there. We can use this starts at text, and then we can see that it starts at index 7, which is 1, 2, 3, 4, 5, 6, 7, the 7th index of this longer sentence. Finally, another thing that we can do is replace all the instances of a piece of text with another piece of text, which we use the replace segment. And that's super self-explanatory. All it does is finds all instances of the word is and replaces it with the word was. So here in this sentence, we have 2 segments with the word is, and we can just replace it with was. So now it's Kevin was watching TV shows, he was relaxing. All right, so those are all the slides and different functions for you guys. I think we have a few questions, but basically, you'll do some. Dr. Meng also messaged basically like we have some step-by-step projects that are going to use all of these things later on. This was more of the fundamentals, and if you're worried about if you forgot things, don't worry about it too much because you're going to just learn along the flow. The great thing about around the flow of things, like great thing about MIT App Inventor is that everything is kind of all the lines of code are pretty explicit on what they do, and you can also just always experiment with things if you're worried about forgetting. So basically, what I'm going to ask you guys now is if you have any other questions. I'll be staying on for a little bit, but just let me know if you have any questions. But other than that, that should be it for today. Thank you guys